Ganesh, can you listen?
Yes, sir.
Shall I start?
Yes, sir.
Okay. See, in the module 4, you have in module 4, you have a new concept, intermediate modifying system. Intermediate modifying system. Say in 3 stages, say for example, the first stage and the third stage, in between that, you have intermediate stage, that is intermediate modifying system. So here, the intermediate modifying system may be rectifier, amplifier, or any amplification method. That may be mechanical, that may be hydraulic, that may be electronic or electrical. So that is the intermediate modifying stage is the second stage in the measuring system. Usually the signal which is coming from the primary stage, which is amplified and which is fed to the final stage. Say, for example, the electronic weighing machine, the force acting on the sensor is converted into voltage signal. So before that, it is converted into analogous signal. Analogous signal is converted into voltage signal. Voltage signal is converted into digital signal. Then the digital signal is fed to the digital readout. So in between the primary stage and the readout, that is the digital output. In between that, there will be an intermediate stage where the input signal, which is amplified and fed to the final stage. The name itself indicates intermediate modifying system. That is nothing but the stage in between the primary stage and the final stage. In between that, there will be an intermediate stage that is called second stage also. Next, to come to the point, the mechanical system. See, all of you know that the primary signal or the first stage signal, which can be converted, amplified, rectified, and which is fed to the next stage. But in case of mechanical system, for this, a good example is gearbox. See, all of you see the gearbox or rack and pinion arrangement in the dial indicator, rack and pinion arrangement in the dial indicator. See, the small movement of plunger, say for example, the small movement, maybe 1 millimeter. If you touch the plunger of the dial indicator, you have thousands, you have more than 1,000 times of rotation of the dial in the dial indicator. So that is the small movement of 1 millimeter is converted into the 1,000 times or 10,000 times. That is nothing but intermediate modifying system. So in case of dial indicator, this is the rack and pinion arrangement. From that, you have the amplification, that is nothing but the mechanical intermediate system. Mechanical intermediate system. Next, come to the point. In mechanical intermediate system, what are the problems you have while measurement, while carrying out the measurement? Say the mechanical advantage gain, that is nothing but input, the ratio of input to the output. Input to the output. That is called kinematic linearity. That may be mechanical linkage, that is the rack and pinion arrangement in case of dial indicator, or the amplifier, or the any instrument which amplifies the input signal That is nothing but the small amount of input signal which is amplified into the large amount. Small amount is amplified into the large amount. That you can say mechanical advantage that can be defined. That is the ratio of output displacement to the input displacement, or you can define in the velocity form. That is the ratio of output velocity to the input velocity. Next, come to the point, that is the reflected inertial amplification. Say almost all the instruments you have gear and varum, rack and pinion, or belt drive, or air drive, or chain drive, you have some inertial amplification. That is nothing but the pickup signal. That is nothing but pickup signal. That is nothing but pickup signal. There you have reflected inertial amplification that can be defined Fi or equal to sigma A delta Fi. That is the total reflected inertial force at the input and the mechanical gain. See, last definition, that is the mechanical gain is the ratio of output to the input. The same way, that is ratio of output to the input or amplification. Delta Fi is the change, the inertial force increment at any point in the system. That is nothing but the reflected inertial amplification is due to the linkage or due to the gearing system or due to the belt drive, the amplification is increased. That is nothing but the small pulley to the bigger pulley or small gear wheel to the bigger gear wheel. Say, in that case, what will happen? You have a two gear wheels, one bigger gear wheel and the smaller gear wheel. The diameter of the bigger gear wheel is 100 millimeter and the diameter of the smaller gear wheel is 20 millimeter. Say, if one rotation of the bigger gear wheel, which gives you 5 times of the smaller gear wheel, that is nothing but reflected inertial amplification. Next, come to the point, the temperature problem. The temperature problem is always present in mechanical measurement. So that can be minimized or that can be avoided by taking the average of all the results. By taking average of all the results. Say in this case, temperature problem. Say for example, the temperature problem is coming from the environment, weather condition, and the temperature of the instrument or the humidity or lesser temperature or higher temperature, the room temperature. Say for example, we expect room temperature in between 25 to 30, but in case of measurement at 10 o'clock you may have 30 degree, but 1 o'clock you may have 35 degree, 3 o'clock you may have 37 degree. Due to the temperature problem, there may be error in the measurement. That type of problem always arises in measurement. So for that reason, the temperature problems must be minimized or minimized. One second, please, all of you. ಅದು 30 ತರ ದುಡ್ಡು ಬರುತ್ತೆ ಅಂದ್ರಲ್ಲ ಕೊಡ್ತೀರೇನೋ ಅಂತ ಕೇಳಿ. ಅದೇ ಹೇಳಿದ್ರೆ ಸರ್ say the temperature problem always present in all the type of measurement. That is nothing but the environmental problem. That's the environmental temperature and the humidity, the temperature inside the laboratory, temperature outside the laboratory, and all those things which causes the which causes the change in the result of the measurement. So you might have seen the thermal expansion and thermal contraction. Suppose in some of the countries you have temperature -14, -13, like that. In some of the countries you may have temperature 40 degree, 47, 50, or like that. So in that case, what will happen? Due to the thermal expansion of the metallic components present in the measuring instrument, or due to the measuring media, there will be thermal expansion or thermal contraction due to the temperature. If the highest temperature is present, say for example 45 degrees centigrade, then you have the thermal expansion. That's the one type of problem we always observe in mechanical measurement. In some of the countries, for example, in European countries, the temperature may be -13, -14, or in sometimes -28 degrees centigrade. In that case, what will happen? Thermal contraction takes place. Due to that, there will be change in the result. So this type of error can be minimized by taking the average of the results of the measurement. From that, you can avoid the temperature problem up to some extent. So in that case, there will be a few variations you observe, that is a zero shift. Zero shift. See, always what you have to do is, before measuring anything, before carrying out the measurement, you have to adjust the instrument to read zero. Read zero. That is nothing but null balance. Null balance. But in case of zero shift, what will happen? Instead of reading zero, the instrument reads the positive reading, that may be 1, 2, 3, like that. So in case of pressure indicator, that is in the air compressor tank, that's present in the air compressor tank. Say if there is no pressure inside the air tank, even though there is no pressure in the air tank, the dial indicates 1 or 1.01 or like that, or 1 or 2. That is the zero shift. That is also called as zero reading or no load condition. That is known as zero reading or no load condition. So in that case, what you have to do, bring the instrument to read zero, or adjust the instrument to null balance. Adjust the instrument to null balance. Next, come to the point, scale error. These two are very, very important. Zero shift and scale error is very, very important for mechanical engineering. That is nothing but a measurement. That is the mechanical measurement. The scale error, say that the zero shift is the one case. Other problem is temperature variations. And scale error, that is, say after using of micrometer for 10 years, continuously using the micrometer for 10 years or 15 years, or the vernier depth gauge or vernier height gauge or vernier caliper, or any measuring instrument where you have the gears, where you have mechanism, where you have rack and pinion arrangement. Due to the continuous use, there may be wear and tear. There may be wear and tear. Due to that, there will be an error in the scale. The error in the scale. That is nothing but the scale error. Due to the continuous use of instrument for 10 years, 15 years, there will be problem with the mechanism, problem with the rack and pinion arrangement, or any instrument where you have the spring, the loading, unloading of the spring, which takes place while carrying out the measurement. After continuous use, there will be a less tension in the spring. For that reason, you will not get accurate result. For that reason, you may have the wrong scale, wrong reading. You observe the wrong graduations on the instrument, or wrong reading in the instrument. That is nothing but a scale error. the scale error also minimized by using the average method. Taking average of the results, you can minimize or you can avoid the scale error problem in the measurement. Next, you come to the point, the electrical intermediate modifying system. Electrical intermediate modifying system. Say the intermediate modifying stage is very much required for measurement. So the intermediate, the name itself indicates before and after the measurement. That is the primary stage to the final stage. There may be an intermediate stage that is very much essential. In that case, you have the input circuitry, which is used as the intermediate electrical modifying system. Electrical modifying system. In that, you have the simple current sensitive circuit and also you have ballast circuit. In your syllabus, you have only ballast circuit. Ballast circuit. So all of you observe here. This is the ballast circuit. Here, the output can be measured. The voltage. The output is the voltage. RB is the rheostat resistance. RB is the resistance. KRI is the rheostat. That is the K is the constant. RI is the rheostat resistance. And EI is the input voltage. Input voltage. See here. Here, say all of you observe here. Here you have the ballast resistor RB and the rheostat resistor Ri and the constant K, and this is the voltage indicator EO, and this is the initial input to the circuit EI. Through the battery, you are providing initial voltage to the circuit. This is the ballast resistance voltage indicator. This is the rheostat resistance. This may be the reading. This may be the measuring instrument. This may be the measuring instrument. Say, before supplying the electrical voltage to the circuit through the ballast resistance, adjust the voltage indicator to read 0. That is, adjust the voltage indicator to null balance. Null balance. That is nothing but the instrument is made to read 0. That is null balance. The instrument reading, that's in the resistance. That's the resistance. You can measure the voltage or measure the current or anything. That's the measuring instrument. That may be the measuring instrument. Or in case of a surface roughness measurement, you have surface roughness tester. You can employ here. Due to that, the voltage indicates that's in millivolts. That's in millivolts. This is the one method you can use. Who is writing on the screen? You can use this circuit as the intermediate modifying system for measurement of surface roughness. Next, come to the point. Very, very important for mechanical engineers. That is the Wheatstone bridge circuit. Wheatstone bridge circuit. Say, you have already studied the Wheatstone bridge circuit. Here you have 4 resistances: 1, R1, R2, R3, and R4, and the excited voltage is V and the output voltage is E. Say, this Wheatstone bridge always used in measurement of axial strain, measurement of bending strain, measurement of torsional strain. Later classes, you study the axial strain, bending strain, torsional strain by using the V-stone bridge. That is, by fixing the strain gauges on the shaft, it diametrically opposite to the position of the shaft. You can fix the resistances on the shaft and measure the strain at that particular point. That is strain measurement. A strain can be measured using the relation R1 by R4 equal to R2 by R3. What do you understand from this relation? Say in this bridge circuit, you have 4 resistances. You can fix the resistance R1 to read bending resistance. Connect these 2 points. The resistance which is attached to the cantilever beam, connect to R1 to the cantilever beam for measurement of bending strength. Apply the load on the cantilever beam. Then what will happen? That is, before measuring the excited voltage in the circuit, before adjust the bridge to read 0, bring the bridge to read 0, that is null balance. Then connect R1 to the strain gauge on the cantilever beam and apply the load on the cantilever beam, and then see the difference in the resistance R1. Then see the difference in the resistance R1. Before that, you know the resistance R2, R3 and R4. You know the values of resistance R2, R3 and R4. You don't know R1. So which is coming from the cantilever beam through the strain gauge that you can connect to the R1. By substituting the values here, you can calculate R1 equal to R4 into R2 by R3. Or you can substitute the values R1 here. That's the difference in the reading. You sub difference in the reading, that will give you the values of the resistance R1. That is nothing but the excited voltage, the output. That is the output. What is the output which is coming from here? That is the voltage, the output which is coming here. It is directly calibrated in terms of strain units. Say, you know the values of R2, R3 and R4. R1 is coming from the strain gauge fixed on the cantilever beam. Substitute here. Then see the excited voltage here. So this voltmeter, this is the millivoltmeter, gives the reading which is calibrated directly in terms of strain units. You have the strain which is in voltage form. Convert that into the strain unit. That is strain unit. See, today we discussed about the mechanical system, that is the intermediate modifying system. Say in the measurement system, say in the block diagram, all of you observe in the block diagram, there will be 5 stages are there. In the second and the third stage, you have intermediate modifying system where the input signal which is amplified, filtered or according to the requirement. Whichever the amplified input which is fed to the final stage, That is the first portion, first concept in intermediate modifying system is a mechanical system. That is the nothing but primary detector transducer. In case of plunger, in dial indicator, that is considered as intermediate modifying system. See, in that, the small movement of the plunger, you may have 1,000 times or 10,000 times rotation of the dial indicator. That is the primary detector transducer. Next, come to the point. The kinematic linearity can be defined as mechanical advantage. or mechanical gain. The mechanical gain can be defined as the ratio of output to the input, or the ratio of output velocity to the input velocity. Next, come to the point. If you have chain drive, if you have gear drive, if you have belt drive, there the inertia, reflected inertial amplification is very much essential, because the rotation of the wheel, rotation of the gear wheel, rotation of the pulley, for a bigger wheel to a smaller wheel, or smaller wheel to the bigger wheel, the reflected inertial amplification is very much essential for measuring instrument. Next, come to the point. All of you observe the temperature problem. We already discussed the measurement of oil inside the laboratory at different time intervals. The instrument is same, the oil is same, but due to temperature of the environment or in the laboratory, which makes the different reading. Say that is nothing but the change. That is the temperature problem. The temperature problem can be minimized or avoided by taking the average of measurement, the average of results of the measurement. In temperature problem, we observe two types of problems. One is a zero shift. Say the instrument cannot read a zero, which shows some shift, that is, which may read 1 or 2 like that. That can be avoided before starting the measurement. Adjust the instrument to null balance or 0. Next, come to the point, the scale error. If you use continuously the any instrument, for example, micrometer, vernier caliper, vernier height gauge, or vernier depth gauge, if you continuously use for 10 years or 15 years, there may be problem with the gates, or with the chain links, with the mechanism, or with the rack and pinion arrangement, or you may have spring in the measurement. Due to the loading and unloading of the spring, after continuous use of 10 years or 15 years, there may be less tension in the spring. Due to that, there may be error in the reading. That is nothing but a scale reading or scale error. Next, come to the point, the electrical intermediate modifying system. So here you have two in your syllabus. One is ballast circuit, other one is keystone bridge. The ballast circuit is the input circuitry. So from this, you can provide the intermediate stage where you need the amplification of the input signal. From the input signal can be amplified by using ballast circuit. Here you have the ballast resistance RB and the measuring instrument, that is a KRI. That is KRI. That's the rheostat or measuring instrument. And this is the output from the circuit. That's the voltage indicator EO. So before measuring anything, you adjust the ballast circuit to read 0. That is the voltage indicator. Voltage indicator shows 0 reading. Adjust the instrument to read 0. Then this is the input circuitry. This is used as electrical intermediate modifying system. Next, come to the point, very, very important. So in strain measurement in the 5th module, you have to use the keystone bridge circuit. Say here you have 4 resistances, R1, R2, R3, and R4. Say, so for example, fix the resistance R1 on the cantilever beam for measurement of bending strain. You know the values of resistance R2, R3, and R4, and the R1 is coming after loading the cantilever beam. Substitute here, you have the answer. So after loading the specimen, so before reading, adjust the millivoltmeter. Says all of you observe here A, that is the output of the keystone bridge. Adjust the bridge to read null balance or 0 reading. Then load the specimen, that is the cantilever beam, and there will be a change in the resistance R1 due to that change in the voltage T. So this much is enough for you today's class. I will continue in the next class. I have stopped at this stage. Now I make unmute to all. So if you have any question, please ask me. Harshavardhan, can you listen? Ganesh, can you listen?
Yes, sir.
Okay. You have any question on intermediate modifying system?
No, sir.
Okay. Now I stop this stage and I will continue in the next class.
Yes, sir.
ಅಲ್ಲಿ ದೊಡ್ಡ ಉದ್ರಿಸಿದಾರಲ್ಲ